Okay, fine young scholars, today we are going to look at the general graphs of the tangent cotangent curves. Then we'll do a couple of examples where we're actually graphing ones that are beyond just the base graph. So let's come up with what the tangent graph looks like. If we substitute in 0 radians or 0 degrees in for x into this general y equals tan x function, let's see. If we put in 0 radians or 0 degrees, we know tangent is y over x. So at 0 degrees on the unit circle, we're at the point 1, 0. Y over x would be 0 over 1 or 0. So over here on our graph, our x represents the degree measure. So at 0, it is the point 0. The tangent function's value is 0. Okay? All right, let's go up to pi over 2. Let's go up to pi over 2. So at pi over 2, and I'm going to make that my second hash mark over here. Okay? If I substitute in pi over 2, the tangent of pi over 2 puts me right up here at the point 0, 1 of my unit circle. So y over x, well, that would be 1 over 0. 0 is under, so we know that it is undefined. And graphically, when something is undefined, that means there is an asymptote, or fondly referred to as an asymptote. Okay? All right, how about, I'm going to kind of skip around a little bit here. I want to figure out what's going on in this graph at negative pi over 2. Well, negative pi over 2 would take me down to 0, negative 1 on my unit circle. And if I take the tangent there, y over x, that would be negative 1 over 0. And again, 0 is under, so it's undefined. And at negative pi over 2, we also have an asymptote. Okay, so we've got a point at the origin. We have two asymptotes. Let's investigate what's going on between those values. Well, between 0 and pi over 2 would be pi over 4. Let's see, figure out what's going on there. So the tangent of pi over 4, we know that at pi over 4 in a unit circle, that's radical 2 over 2, radical 2 over 2. So y over x, which is the tangent, y over x would be radical 2 over 2 over radical 2 over 2, or 1. So at pi over 4, the tangent of pi over 4 is 1. Okay? Let's figure out what's going on from 0 to negative pi over 2. Well, that would be at negative pi over 4. Well, negative pi over 4 over here on a unit circle, negative pi over 4, that would be what? Radical 2 over 2, negative radical 2 over 2. So the tangent at negative pi over 4 is y over x. So that would be negative radical 2 over 2 over radical 2 over 2, which gives us a value of negative 1. Okay? This is all we need right here. So the tangent function, okay, is going to approach an asymptote going to the right, going to positive infinity, and then it's going to approach negative infinity as we go to negative pi over 2. So what are the characteristics of a tangent curve? Well, its period is pi, okay, because it's going from negative pi over 2 to pi over 2. So its period is 5. Okay, when we go to find intervals, we're going to do the same thing that we did with the sine cosine curves, but instead of a 2 pi divided by b, it's going to be pi divided by b. Okay? Oh, Nikes. No, I'm sorry. To find the intervals, we're going to take whatever the period is, and we're going to divide by 4, just like we did with sine and cosine curves. Okay? All right. So the general period of a tangent function goes from negative pi over 2 to pi over 2, so it is pi. Okay? Whatever the amplitude is, that is that value that's out in front of the tangent function, really no amplitude exists in a tangent curve because by definition amplitude is a maximum point that it reaches, and the tangent curve is going on and on to infinity and negative infinity. But that a value that we use, which in this case is 1, helps us to find that pi over 4 and negative pi over 4. Whatever that a value is, when you get to this interval, that's how high it's going to be. So if this happened to be, for example, a 3 tan x, then this pi over 4 at this interval, we would have been up here at 3 already. So that's how we can kind of use that a value. Okay, let's go on to the cotangent curve. All right, so we know that cotangent is x over y as opposed to y over x. So let's start by just sticking 0 in again. So if we put in 0, the cotangent of 0, that puts us on our unit circle at 1, 0. The cotangent ratio is x over y, which would be 1 over 0. 0 is under, so on a cotangent curve, at 0 radians or 0 degrees, it's undefined, so there exists an asymptote. Okay? All right? What about at, let's do what we did with our last. We're going by intervals of pi over 4. Let's check out and see what's going on at pi over 2. At pi over 2 on the unit circle, we're at the ordered pair 0, 1. Okay? Cotangent is, again, x over y, so that would be 0 over 1 or 0. So at pi over 2, we're at the point 0. Okay, we're going to carry on here. So I actually need a point here and another point here. So if I'm going up by pi over 2's, if this is pi over 2, then my interval must have been pi over 4. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which would be pi. Okay, so let's carry on here. So far we have an asymptote at 0. Let's figure out what's going on out at pi. So if we take the cotangent of pi over here on our unit circle, we're at the ordered pair negative 1, 0. Cotangent is x over y, or negative 1 over 0. 0 is under, so at pi it is undefined. Okay? How about pi over 4? At pi over 4, we're at the ordered pair radical 2 over 2, radical 2 over 2. So x over y is going to give us 1. So at pi over 4, we're up here at 1. And at 3/4 pi, we're at the ordered pair negative radical 2 over 2, radical 2 over 2. So the cotangent ratio x over y would be negative 1. So a cotangent curve looks like this. So what are the characteristics of a cotangent curve? Well, cotangent curve, period is the same as a tangent curve, okay? The period is still pi. The cotangent curve is kind of negative sloping, and it goes from 0 to pi. Let me say that again. So a cotangent curve, you'll notice, kind of has a negative slope to it, and it goes, one period goes from 0 to pi. Okay? Let's go back and look at the tangent curve. The tangent curve, its period is also pi, but it's kind of, it ranges from negative pi over 2 to pi over 2, and it's positive sloping, if you will. It's positive sloping. Okay? So hopefully you see the differences between those two. Okay, so let's put this to work. Let's try to graph this function. Okay? So the amplitude, if you will, again, a true amplitude does not exist. But that value, A, is negative 2. Okay? The period. Well, we know the normal period of a tangent curve is pi, and we're going to divide by b, and b is 2. Okay? So the period of this tangent curve is going to be pi over 2. Its interval is going to be pi over 2 divided by 4, or multiplied by 1/4, which is pi over 8. Okay? There is no phase shift. There is no vertical shift. In the quick sketch, okay, so this is, I purposely chose ones that weren't going to be easy. Okay? The fact that the A value is negative, just like with sine and cosine, it flips it. So a normal tangent curve has kind of a positive sloping looking thing, but if the A value is negative, that's going to flip it. So basically, the negative tangent curve, I'm going to erase this now. The negative tangent curve looks like a cotangent curve. Hopefully that makes sense. Okay, so our intervals are pi over 8. So pi over 8, 2 pi over 8, which is pi over 4. And then in the other direction, negative pi over 8, negative 2 pi over 8, or negative pi over 4. Okay? This is a tangent curve, which we know is going to be, half of it's going to be on the positive x and half of it's on the negative x. Okay? We know that at 0, it's 0. Okay? And in two intervals away in both directions, we're going to have asymptotes. Okay? And then again, at pi over 8, if the A value is 2, then that means it's going to be already at 2 by the time it gets to that interval. All right? The normal, now this is where we look at our quick sketch. Normal tangent curve is positive sloping, but this is going to be negative sloping. So at negative pi over 8, we're already at 2, and at pi over 8, we're already down to negative 2. Okay? And then it approaches the asymptote here, and it approaches the asymptote here. There's one period of that graph. Okay? All right, we've got one other example I'd like to do. And again, I've chosen ones that aren't necessarily easy. The amplitude, again, doesn't really exist, but the A value is 3. Okay? The period, well, the normal period is pi. The B value here is 1/2. So if we invert and multiply, this is just going to be pi over 1 times 2 over 1, or 2 pi. Okay? So the period is 2 pi. Interval, I'm just going to divide by 4. So our interval is going to be pi over 2. Okay? Phase shift doesn't exist. Vertical shift doesn't exist. If they did, we'd treat them the same way we did with our sine cosine curves. And this is a positive cotangent curve, and cotangent curves are kind of negative sloping, if you will. Okay? So here we go. Intervals are pi over 2. This is a cotangent curve. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is 2 pi. Okay. Cotangent curve starts at 0, and at 0, it gives us an asymptote. Okay? The amplitude is 3. It is negative sloping. So let's see here. Boom, boom, boom. 1, 2, 3. So at pi over 2, it's going to be all the way up to 3 because this thing is going to be negative sloping. At pi, it's going to be 0. At 3 pi over 2, it's going to already be down to negative 3. Again, that's how we use the the A value, okay? And then at 2 pi, that's going to be our other asymptote. That's why we're still dividing by 4, okay? Because we still have 4 critical points. The asymptote is where we start. The first interval gives us this value. Second interval where it's going to be a 0. Third interval, this value. And then the last one back where we have an asymptote. So this graph is going to go down and it's going to look like that. Again, approaching the asymptotes. Okay. Hope this is good enough to get you going, guys.